Hi, I'm going to share an activity that I did with my fourth grade class. This is an activity I did with a small intervention group, and we were doing an activity called a strategy chat. I call it a strategy chat in my room. It is very similar to a number talk. However, our goal is simply to find a strategy that would help us solve this equation that is given, but we are specifically not trying to find the answer. I find that that small modification can make a difference when I want to create a low floor, high ceiling activity. That's especially in my intervention groups. Sometimes a traditional number talk, especially if they are not used to using these tools and thinking this way yet, can be a little too far off the ground for some of my students who don't have those computational skills yet. So because they don't have the computational skills, they lose out on really focusing on the strategies. So my solution, a strategy chat. Low floor, students don't have to have an answer. High ceiling, there can be a lot of different ways we can group, regroup, break apart, think about numbers. The first thing I would do is I would have this rec on the table in front of all of the students where they could see it and interact with it. I would be writing on a piece of construction paper or something where students could see, and we would record everyone's strategies. My focus in this group, in my recording, was to be continuing to reinforce the newly introduced concept for us in fourth grade of using parentheses and how parentheses can set off different steps or different parts of an equation. So to start with, we built the number 36 by sliding all our beads over 10, 20, and 30, and then 6. And we all agreed that when we have to add 25, that means we need to put 25 more beads with the beads we already have, and that we have to then figure out how many beads there are if we put them all together in one large group. So then I gave something time and asked students to start sharing their strategies, how they would figure this out. I strategically chose my student who had the lowest expected entry point so that she was able to feel successful in the activity. Her entry point was counting by ones. Her strategy she shared was I would count 1, 2, 3, 4, 5. So I said, okay, I'm going to write that down this way. I'm going to write the words count by ones as your strategy. Then I said, who else has a strategy? We proceeded to go that way. The second strategy that was shared was to count by tens. And I asked the student to show me how you would see tens in this problem. So they reached out and moved the beads to show the groups of 10. I said, oh, you counted by tens first. Now I see the tens. But were you done with all the beads after you counted by tens, or did you do another step? That's when they said, oh, well, I have these extras, but they're not tens, so I would have to count them on by ones. So, okay, sounds like you have two steps. You first said you were going to count by tens and count up all the tens. So since we have more than one step, I'm going to use these parentheses to show each step is separate. So first we counted by tens, that's one step. And then you said you were going to add on the rest of the pieces. So I'm going to put plus. And you said the strategy you were using was count by ones. So I'll give that its own parentheses for his second step. Right? And we reset. The next student said, well, if I did the same thing and counted by tens, but then I would count and by fives instead of counting by ones. I said, oh, show me how you would do that. So he said, well, there's a 5 here if I take this one off and a 5 here. So I could count by tens for this part and then add on the count by fives and then add on 1 at the end. I said, oh, so that sounds like 3 steps. Count by tens, And then another step of count by fives, and then a plus one. And since the one is just by itself, it doesn't have anything else, it doesn't need parentheses, it can just sit there by itself. All right, here we go. Anyone else have another idea of how we could solve this equation? The next student said, well, we could just add up all of the tens and then add up the ones. So 30 plus 20, and then 6 plus 5. I said, okay, show me where you see that in the beads. So they pushed these out and they said, well, here's the 30 from the 36, and then we have the 20 from the 25. So I would add those together first. So, oh, okay. So I'm going to put that in here and say you would add your tens first. So you said you would add 30 plus 20 first. And then what would you do? And I said, well, then I would add the 5 plus the 6 because that's what's left in the ones place. So, okay. So then we would add the 5 plus the 6. Okay. So we see that when we had 36, there's a 30 and a 6. Right there is the 30. Oh, and then we would have the 20 and the 5. Actually, I should have written that backwards. Or not written that backwards. I want to make sure that as I'm writing it, even if the student says it backwards, I want to know that the 36 is kind of still collectively one number. So I try to keep the order the same. 30 in the first spot, 6 in the first spot, 20 in the second spot, 5 in the second spot, even though the student might have said it backwards. Another student shared that their strategy was to they would count by tens and then add another 10, or add another 10 and a 1. I said, oh, tell me more about that. I said, well, first count these tens, and then there's another 10 here. This and this makes 10, and then there's a 1. I said, oh, that sounds like you actually did 3 steps. It sounds like you counted by tens first, and then you said you added another 10, but you said how you got that 10 was by the 2 5s. I said, how did you know that those 2 5s made another 10? And I said, well, it's 2 times 5 is 10. And that language was kind of what I was pushing for. So that was an interesting thing this here. So I said, well, you said first you would count by the tens, and then you would add another 10, but how you got that 10 was with 2 times 5. So I'm going to write it this way, 2 times 5, because that's how you made a 10. Is that right? And they said, yeah. And then you said you added on the 1, and we would write it this way. Okay. What else? What else do we see? At that point, I had a student say, I see 12 times 5 plus 1. I said, oh, how do you see that? So they moved the beads. And I said, here's 12 fives. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 groups of 5 is 12 times 5. Plus, you have to add the extra 1 at the end. And we kind of talked about it with the group, made sure everyone saw what he was doing and understood. And I said, okay, so it seems like you have 2 steps. So I should put my parentheses for the 12 times 5 for 12 groups of 5, and then add on a 1 at the end. All right. We ended up with a couple of more answers. We had a student count by 2s plus 1. And we also had a student who decided they could do multiplication, but they did 5 times 10 plus 2 times 5 plus 1. But every time I would talk it through with them, we would discuss it and make sure everyone understood each person's thinking. We could make sense of it with a physical representation, and then we would look at how it would turn into a notation format.